Hello everybody, glad to see you. Today we're going to talk about how we can implement GD&T for a component. We need to follow several steps that are listed here. First, we need to define datem references, and then we are going to implement location, orientation, and form, and in case we may need to use profile symbol and run out. GD&T is useful. Car is useful. That's why I'm going to say GD&T can be represented by LOL car. This LOL car is here in the middle at top. We can see this LOL is inside this car. Location, orientation. The last L, it can be in this form. On middle we can see here. Bottom we can see if I'm going to add this line here, it became location, orientation, and form. Here we can see inside the car, and this shape is going to represent profile symbol, and we are going to have two wheels. The wheels is going to represent somehow run out symbol, and all of them are covered with this D. If I'm going to read it vertically, it is D here. This D in red color is going to represent datem references. Now we can see here, for example, at top right, this funny guy is going to have this LOL car here. Or at this corner at bottom, we can see here, bottom left, we are going to have this funny guy. He's going to have this LOL car. Here, as we have mentioned, the first item is to define datem references. For this example, as we can see here in the middle, we are going to have three components that are in contact. The contact areas are going to represent with the same color as we can see. This blue face is going to see this blue face. This green from part A is going to see this green face from part C. As we can see, whenever we are going to have function for that plane or surface, we may need to define that plane as a datum reference or reference plane. And then we are going to qualify that, and then we are going to implement location, orientation, form in case we are going to implement profile and run out as well. Please keep in mind LOL car. Whenever I'm going to have example for you, I'm going to present the assembly. Whenever we are going to have the assembly, we can see what is the function of that surface. If they are in contact, we are going to define it as a datum plane, and then based on that, we are going to implement GD&T. Normally, I cannot define GD&T for one component alone. I should see the assembly, and based on the function, I'm going to implement GD&T for that assembly. In this example, I'm going to have this yellow component and this green component, and they are in contact by having this M8 bolt. We are going to have 8 of them. And now I would like to implement GD&T for that. As we have understood, we should implement this LOL car. First step is datum plane. For today, I'm going to talk about these datum planes for this example, and in the comment section, I'm going to implement GD&T for that. What should be the TZ for each symbol? Yes, for now, we are going to have these small areas in contact, as we can see here at top. I'm going to define it, these 8 small surfaces in contact as an A. You can see here. I'm going to show you by mouse here. What we can see here on left hand side, this area is not that much big, they will be in contact, they are important. That's why we are going to define it as A. In order to, let's say, qualify it or machine that surface, this surface as a, I need to I need to use a big surfaces to fix my component, and my component should be sit on this surface. That's why I'm going to define it B as well here as a secondary reference plane here, or B, let's say, and A and B are connected, dependent to each other somehow. And that's why I'm going to qualify B with this flatness. And then I'm going to define A based on B because I'm going to qualify B by flatness. However, you can see here at bottom, I'm going to qualify the surface as well because they are in contact. They should have this flatness as well. But for now, let's define A here and B here. We are going to eliminate 3 degrees of freedom, 2 rotation, and 1 displacement. If I'm going to fix this component, I need to eliminate other 3 DOF. If I'm going to implement C here, the axis of this big surface, C, I'm going to eliminate 2 more displacement here, and then I'm going to define D, as you can see on left hand side, D. I'm going to fix my component. It is fixed now, and then easily I can implement my GD&T for this component. For now, I would like to close this session. In coming session, I'm going to continue talk about this example, and later on, I'm going to talk about how we are going to implement GD&T for that, let's say, green component here. And then we go ahead, we are going to have several examples. Thank you for today. I hope you enjoyed. See you next time.